A ship is moving above a highway, not beside it, above it. Cars are passing underneath while the ship keeps going like this. It's completely normal. A few miles away, entire neighborhoods sit below sea level. In some places, the ocean is several meters higher than the people living behind the dikes. Think about that for a second. Millions of people go to work, take their kids to school, and sleep at night with a wall holding back the North Sea. And that wall is not just part of the landscape, it is part of the country's survival system. Pumps have to keep moving water. Gates have to close when storms come in. Sensors, barriers, canals, and dikes all have to do their jobs. Because what happens if one pump stops? What happens if one gate does not close? What happens when the sea rises faster than anyone expected? The Dutch did not build all of this because they loved giant engineering projects. They built it because they learned what the water could do. On the 31st of January 1953, a powerful storm pushed into the Netherlands. In the early hours of the morning, the dikes began to break. Most villages were still asleep. By the time the water stopped rising, 1,836 people were dead. Huge areas were underwater, and entire communities had been torn apart. That night changed the country forever. The disaster didn't begin in the Netherlands. It started far to the north, with a powerful storm forming south of Iceland. As it grew stronger, it pushed the North Sea straight toward the Dutch coast. There was nowhere for that water to go. Around 4 in the morning, the dikes began to fail. Most people were still asleep. They had no idea that the walls protecting their homes were already giving way. By sunrise, entire villages were underwater. Families were separated in minutes. Some never found each other again. When it was over, 1,836 people had lost their lives. More than 150,000 hectares of land were covered by floodwater. One village lost 305 people before daylight. In one desperate moment, a local mayor gave an unbelievable order. A ship captain was told to crash his own vessel into a broken dike, hoping it would slow the water long enough to save the people behind it. It worked. Millions of lives were protected because someone was willing to make an impossible decision. What makes this story even harder to accept is that none of it came out of nowhere. For nearly 20 years, engineers had been warning that something like this could happen. Report after report was ignored. The man who kept sounding the alarm never lived long enough to see people finally listen. Just 17 days after the flood, the Dutch government made a promise that would change the country forever. 2 simple words: never again. From that moment on, the goal was no longer to recover from the sea. It was to make sure the sea would never catch them unprepared again. After the flood, the Dutch knew one thing: fixing a few broken dikes wasn't going to solve the problem. They had to think much bigger. One engineer, Cornelis Lely, had already come up with an idea years earlier. Most people thought it was impossible. Some even called it crazy. His plan was simple to explain, but unbelievably hard to build. Instead of protecting every mile of coastline, why not shorten it by almost 700 kilometers? That meant building a single dam straight across open sea, a wall nearly 32 kilometers long. The project pushed engineering further than anyone had tried before. Around 10,000 workers showed up. 27 dredging ships worked non-stop. 4 construction sites moved at the same time. More than 36 million cubic meters of sand and clay were pulled from the seabed and piled up to form the dam. But moving material wasn't the hardest part. Keeping it in place was. The waves kept washing the clay away, so the crews laid huge woven willow mats across the seafloor first. Those mats gave the new foundation something to hold on to. Then another problem showed up. Shipworms started eating away at the wooden foundation from the inside. Parts of the structure were slowly weakening, so the engineers changed course. The damaged wood was replaced with stronger materials that could survive salt water, and the outer face was reinforced by hand with massive blocks of basalt. Even after years of work, everything came down to one final moment. Only about 50 meters of open water remained. They couldn't close it whenever they wanted. They had to wait for slack tide the brief moment when the current almost stopped. That tiny window was their only chance. Barges rushed in, dumping load after load of material into the gap. 50 meters became 30, 30 became 10. Then, finally, the last opening disappeared. For the first time, the North Sea was cut off from the inland waters. It was an incredible achievement, but it also raised a much bigger question. If you can stop the sea, is that really enough to protect an entire country? Most countries stop once they build a wall. The Dutch didn't. They looked at the water trapped behind the dam and asked a completely different question. What if we turned it into land? So that's exactly what they did. First, they built a ring-shaped dike around part of the lake. Then the pumps started working. Not all at once, little by little. The water dropped centimeter by centimeter until something incredible happened. A piece of the seafloor that had been hidden for nearly 10,000 years finally saw daylight again. At first, it didn't look like land at all. It was wet, soft, and covered in thick mud. Instead of rushing to build on it, they waited. The wind carried reeds into the area, and those plants slowly helped dry and stabilize the soil. Nature ended up doing part of the work for them. Only after the ground became strong enough did construction begin. The roads came first, then the farms, the houses came last. Everything was planned before the first family ever moved in. But once again, the story didn't go exactly as planned. Near the end of World War II, German forces flooded the area on purpose. The engineers had to drain the land all over again. Even after that, another problem appeared. The more water they pumped out, the more the soft clay compressed under its own weight. The new land slowly started sinking. They had solved one problem and accidentally created another. So they changed their approach. Instead of removing as much water as possible, they left enough moisture in the soil to reduce future sinking. Even today, that land depends on 3 pumping stations running around the clock. If they stop, the water starts coming back. Maybe that's the biggest lesson in this whole story. Engineering isn't about finding one perfect solution. Sometimes it's about solving today's problem while staying ready for the one you create tomorrow. By this point, the Dutch knew how to build massive dams, but building them was only half the battle. Getting those giant concrete sections into the sea was a challenge all by itself. Each caisson was built on land first. Then it was floated out to the construction site. Sounds simple. It wasn't. The current kept pushing and twisting those huge concrete boxes. Some started spinning before they reached the right position. The crews had to think fast. They dropped anchors onto the seabed and used heavy steel cables to hold each caisson steady until it could be lowered into place. It worked. But then, a much bigger problem showed up. The engineers realized that sealing every sea inlet with solid dams would do more than stop storm surges. It would also stop the natural flow of seawater. That meant the ecosystems inside those waters could slowly die. Fishermen saw the danger. Mussel farmers saw it too. People began pushing back. For the first time, the question wasn't just, can we stop the sea? It became, what are we giving up if we do? That changed everything. Instead of forcing the original plan through, the Dutch made a difficult decision. They scrapped the solid dam design and started over. It cost years of extra work and billions more to build. But the new idea was smarter. Leave the sea open during normal conditions. Only close the barriers when a dangerous storm is on the way. That one decision changed the entire project. It also left behind an important lesson. A project isn't successful just because it protects people. If it destroys the environment those people depend on, then part of the problem is still unsolved. Changing the design solved one problem. Now they had to build something no one had ever built before. The new barrier, called the Oosterscheldekering, stretched for about 9 kilometers across the estuary. Instead of one solid wall, it would stand on 65 massive concrete piers with 62 giant steel gates between them. Most people see the finished barrier today and think that's the impressive part. Honestly, building it may have been even harder. The engineers couldn't just start in the middle of the water. They built an artificial island first. That island became their factory, where they cast one concrete pier every month for 5 straight years. Each one had to be almost perfect before it ever touched the sea. Next came another challenge. Huge concrete foundation mats had to be placed nearly 30 meters underwater. The target was unbelievably small. They only had about 20 centimeters of room for error, miss by more than that, and everything above it could be out of alignment. At one point, the project almost ran into serious trouble. The crews discovered empty spaces beneath one of the foundations after it had been lowered into place. If those gaps stayed there, the entire structure could become unstable. They didn't panic. Instead, they pumped grout through pipes until every hidden space was completely filled. Only then could the construction continue. Finally came the steel gates. Each one measured about 42 meters wide and weighed roughly 480 tons. Getting them into position wasn't about brute force. It was about patience, precision, and making sure every piece fit exactly where it belonged. Then came the moment everyone had been waiting for. In 1986, Queen Beatrix gave the signal. One by one, all 62 gates lowered into place. Years of planning, testing, and problem-solving came together in a single moment. The barrier worked exactly as it was designed to. Looking back, it's easy to focus on the finished structure, but the real story is everything that almost went wrong before those gates ever closed for the first time. By now, the Dutch had learned how to protect small towns. But Rotterdam was a completely different challenge. This is one of the busiest ports in Europe. You can't just block it off with a permanent dam. Ships need to move in and out every day. So the engineers had to come up with something completely different. Instead of building a wall that never moved, they built one that stayed open most of the time. Only when a major storm is coming does it close. The system is incredible to watch. Two giant steel arms, each weighing about 6,800 tons, sit quietly on opposite sides of the river. People compare them to the Eiffel Tower because each arm is even heavier. When the water reaches a dangerous level, the gates begin to move. They float out onto the river, slowly swing toward each other. Then they fill with water and sink to the riverbed, sealing the entire waterway. Making something that large move so smoothly wasn't easy. Each arm rotates on a single steel ball joint, weighing about 680 tons. It only had one chance to fit correctly. During the first major test, the engineers found a serious problem. One of the gates was sitting 340 millimeters out of level. That might not sound like much, but on a structure more than 200 meters long, it was a huge issue. Instead of starting over, they adjusted the ballast inside all 26 compartments. Little by little, they brought the difference down to just 15 millimeters. Then came the final piece. A computer system called BOS constantly watches the water level. If the sea rises above the safety limit, BOS sends the command to close the barrier. No one has to press a button. The first real storm closure happened in 2007. The system worked exactly as planned. Some people might wonder if it's risky to let a computer make that kind of decision. That's a fair question. Based on the transcript, we know BOS operates automatically, and the barrier includes backup systems. But the video doesn't provide enough information to judge every possible risk. What it does show is this. The Dutch didn't rely on luck. They built a system designed to react before people have time to. After decades of building bigger barriers, the Dutch realized something surprising. Not every problem needed more steel. Some places simply couldn't use giant gates. So they tried a different idea. Instead of lowering heavy steel into the river, they placed 3 giant rubber tubes on the riverbed. Most of the time, you can't even see them. They're hidden underwater, doing absolutely nothing. But when a dangerous storm is coming, everything changes. The tubes fill with air and rise from the riverbed. In about an hour, they become a wall nearly 10 meters high. Simple idea, huge impact. One storm came dangerously close to proving just how important that barrier was. The water rose so high that there was only about 900 millimeters between safety and disaster. That was close enough to make everyone pay attention. The engineers didn't celebrate. They went back to work. They added backup valves, extra air supplies, and more sensors, so the system would be even more reliable the next time. But the biggest change wasn't another barrier. It was a completely different way of thinking. Instead of trying to stop the sea everywhere, they started asking where the water could safely go. They dumped about 21.5 million cubic meters of sand along the coast and let the waves spread it naturally over time. They dug a new river channel about 9 kilometers long, giving floodwater another place to flow. That alone lowered peak flood levels by about 27 centimeters. It doesn't sound like much, but sometimes a few inches are the difference between a city staying dry and a city flooding. They even built wide beaches in front of some dikes. The sand dunes absorbed the force of the waves before the water ever reached the wall. Looking back, that's probably the biggest lesson in this whole story. At first, the goal was to lock the sea out. Eventually, they realized something even smarter. You don't always have to fight the water. Sometimes, the best solution is to give it room to move, while keeping people safe at the same time. When people look at the Netherlands today, it's easy to think one incredible project solved everything. That's not what happened. There was never one giant wall that saved the country. Every project taught the engineers something new. Every mistake forced them to rethink the next design. The flood of 1953 changed more than the coastline. It changed the way an entire country thought about living with water. Over the next 90 years, they didn't build one solution. They built layer after layer of protection. Some barriers close only during storms. Some pumps never stop running. Some beaches are designed to absorb waves before they reach a dike. In other places, rivers were given more room instead of being forced into narrower channels. That's probably the biggest lesson of all. The answer isn't always to build a higher wall. Sometimes it's smarter to open a gate. Sometimes it's better to add sand and let nature do part of the work. Sometimes the safest choice is simply giving the water somewhere else to go. The Dutch never defeated the ocean. They learned how to live with it. And maybe that's why their system has lasted for generations. So, here's the question. If a country that lives below sea level chose to prepare instead of waiting for the next disaster, how much longer can the rest of the world's coastal cities afford to wait?